Hello and welcome to Physics with Amol sir. This is the video for class 9 and today we are starting with the chapter Motion. I hope you have seen the previous video of Introduction to Class 9 Physics. Make sure that you have seen that video and then you have seen this, because otherwise some things will not make sense. The basics of physics have already discussed in that previous video. So let us begin. So this is chapter 8, Motion. Okay. So what is motion? So in physics we define motion as the change in position of a body with time. That is the definition for motion. But I think it is not a new concept for you. If you look around you, you can identify which objects are in motion and which are not. So you will look at a table in front of you and you will say the table is not in motion, it is at rest. Or you will look at your cupboard and you will say the cupboard is not in motion, it is at rest. But you will look at the fan and you will see the fan is revolving and therefore you will say the fan is in motion. Okay. So we can look at an object and if we see that it is changing its position, we say the object is in motion. Fine. That is the meaning of motion. Next, there are various kinds of motion. If the motion is taking place in a straight line, for example, a car that is driving on a highway. Okay. So if motion is in a straight line, we call that motion as linear motion. Linear standing for line, in a motion in a straight line. If the motion is in a circular path, like the motion of our fan or the motion of the earth around the sun, we call that as circular motion. Okay. In this particular chapter, we will restrict ourselves to the linear motion. That is motion in a straight line. Okay. Another thing to remember about motion, motion is a relative concept. Correct? So we always talk about relative motion. What we mean by that? Motion depends upon the point of observation. It is very important from where you are observing, and that is when we define motion. For example, you are standing on a platform, okay, and you see a train is moving in front of you. So you will say that I am at rest and the train is moving. Correct? And every person who is sitting in the train, you will say that person is in motion. Is that correct? So when the point of observation is yourselves on the platform, the train and the passengers are in motion. But if we change the point of observation to the passengers, imagine the passengers are sitting. So passengers are sitting in front of each other. So passengers will say we are at rest and the other passengers are also at rest. Correct? Because they are not moving from their places. They will look at you on the platform. They will see that you are moving backwards. Is that correct? When the train moves forward, any person on the platform seems like he is going backwards. So the train passenger will say that you are moving backwards. They can say we are at rest and the person on the platform is in motion. Okay? So therefore I say motion is a relative concept. Another simple example I will give you. When we are on the earth and you look at the sun. So in the morning, sun rises from the east and it sets in the west. You can see the motion of the sun throughout the day. Correct? So you can say that on the earth we are at rest and the sun is in motion. But we know the real fact. We know that it is actually the earth which is revolving around the sun. But when we are observing from the earth, it seems like it is the sun which is moving. Okay, so motion is a relative concept. I hope that is understood now. So today we are going to see 4 very important factors related to motion. First is distance, next is displacement, third is speed, and fourth is velocity. These are very, very important. Why they are important? When we are going to study motion, we need these concepts. Okay, so let us begin. The first one is distance. First, let us see the definition of distance. Distance is defined as the total path travelled by an object. That is the definition. Very simple? Yes. Now here is a diagram. Imagine you are standing at point A. Okay? From point A you go to your friend's house which is at point B. And you walk total 10 meters. Fine? Then from point B you go, let us say, to a garden at point C, and then from B to C you walk for 15 meters. Fine. So you started from A, went to B, and from B you went to C. So what is the total path that you have traveled? You will say 10 meters plus 15 meters. AB plus BC. So the total length will be 10 plus 15, which is 25 meters. Fine. This is called as your distance. Very simple. Correct. So the total path length that is traveled by an object is called as the distance. Distance is a scalar quantity. I hope you remember scalars and vectors that we discussed in the previous class. Scalars are quantities which can be defined only with their magnitude. Okay. So distance is a scalar quantity. When we want to measure a distance, the SI unit of distance is meters. Please remember, whenever we are going to write distance, the SI unit is always meters. Okay. So this is the case to calculate distance. So basically, whenever we are traveling, correct, the total path that we are traveling, that is called as distance. For example, we start from Tiruvannamalai and we go to Chennai. Correct. If you are going in a bus, the bus is going to travel all sort of ways. It will take turns. Correct. It will take some different paths, and then it will reach Chennai. And we will see the total distance we have traveled is around 180 kilometers. Fine. So this is the meaning of distance. In our vehicles, we have a meter that gives the distance. I hope you know the name of that meter. It is called as the odometer. Okay. I hope you have seen it in your parents' vehicles. So there is a meter which gives the count how many kilometers you have traveled. Correct. That is called as odometer. So remember, odometer gives the distance. Is that correct? So this is about distance. Next, we talk about displacement. Now what is displacement? I will show you the first diagram once again. So we started from A, we went to B, and from B we have gone to C. So what is our initial starting point? Initial point was A. And where did we stop? We stopped at C. Correct? So A is our initial point and C is our final point. Displacement is defined as the shortest distance between initial point and final point. Okay, that we have shown by this dotted line. Getting the idea? So once again, displacement is shortest distance between initial point and final point. So in the diagram, it is shown by AC, and AC you can see is around 20 meters. These are approximate values just for understanding our put. Okay, don't go measuring this. So AC is the displacement, okay, which is equal to 20 meters. So you could have traveled by any path from A to B, B to somewhere, B to C, C to D. Correct? Total path length we call as distance. But when we want to find out displacement, we take into account only the initial point and the final point, and we draw a straight line from initial point to final point. That is called as displacement. So once again, for example, we started from Tiruvannamalai and we went to Chennai. So we have gone from different kind of roads, correct? There have been turns, there have been many different ways, and then we reach Chennai. Getting the idea? So the distance we get is around 180 kilometers. But displacement, we'll have to draw a straight line from Tiruvannamalai to Chennai. Is that correct? That straight line will definitely be smaller than 180 kilometers, right? So displacement is normally smaller than the distance. Fine. Displacement is also measured in the unit of meters. Remember, just as distance. And next thing, displacement is a vector quantity. Okay. Vector quantities are those which can be defined with magnitude and direction. They need direction to be specified. So when you are writing displacement, the initial point and the final point both are important. And the direction is given from initial point to the final point. Correct? So that is the meaning of displacement. So as I said, generally displacement is smaller than distance. But there is one case where distance is exactly equal to displacement. Can you imagine that case? Well, that case is when the motion is in a straight line. Okay? If you are going in a straight line from point A to point B, distance will be AB. At the same time, displacement will also be AB. So if motion is in a straight line without any turns whatsoever, the distance is exactly equal to displacement. Okay? So I hope these two concepts are clear, distance and displacement. Next concept is speed. Speed is defined as distance traveled per unit time. Unit time means 1 second. Okay. So once again, speed is defined as distance traveled per unit time. This is the formula. So speed we write as distance upon time. SI unit of speed is meter per second. Okay. So for example, if we have traveled a distance of 20 meters and to travel 20 meters we took a time of 10 seconds. So we will find our speed as speed is distance by time. Okay. 20 meter by 10 seconds, which is equal to 2 meter per second. Clear? So that is the meaning of speed. Speed helps us to understand how fast we are going, how fast our distance is changing with the speed, with the time. Okay, this is the meaning of the speed. Speed is also a scalar quantity. Remember, okay. So speed is a scalar quantity. SI unit of speed is meter per second. Next quantity is called as velocity. Velocity is defined as displacement per unit time. Okay, so this is the formula. Velocity we define as velocity is equal to displacement upon time. Okay, SI unit of velocity is once again meter per second. Velocity is a vector quantity because it is displacement by time. Displacement was a vector, therefore velocity is also a vector. So what is the difference between speed and velocity? Speed, as I told you, it is giving you how the distance is changing with time. Correct? Velocity only gives change of displacement with time. So what happens is, we have seen that displacement can be smaller than distance. So therefore, same is the case with velocity. Velocity is also generally smaller than the speed. But velocity and speed will be exactly same when the motion is in a straight line. Okay. So I hope these four concepts are very clear. Distance, displacement, speed and velocity. Okay. You should know the definitions and you should also know their SI units. Now, one special thing about displacement. Again, I will show you the initial diagram that we had seen. Okay, so we went from A to B and from B to C. So you will say A to B, B to C. The distance traveled is 25 meters. Now let us say from C you come back to A. Correct? So your path will be A to B, B to C, C to A. You started from A and again you came back to A. So you will see the total distance traveled is 10 plus 15 plus 20. That is equal to 45 meters. Is that correct? So in this total path, you will see the distance traveled is 45 meters. But what about displacement now? Displacement will be 0. Why displacement is 0? Because your starting point is A and your final point is also A. So if you come back to the same point after traveling, we say the displacement is equal to 0. Getting the idea? So if our starting and final point are the same, displacement amounts to 0. And of course you would have guessed the velocity will also be 0 in that case. Okay. So revise these concepts. Next class we are going to see what is meant by uniform motion, what is meant by accelerated motion. Okay.